Good day, everyone. Today, we're talking about angles and the unit circle. All right, announcements and reminders. ACT is a grade that's recorded in the grade book, so make sure that you are working hard studying that to make sure that you master it. Failure of the ACT will result to possible failure of the class, and you will have a full schedule, amongst other things, if you don't take care of your junior requirements. Your project is your responsibility, and you may not have time to do it in class. Now, the good news is you guys will have an extension to get this stuff done, and the due date be done in March. So I will give you that due date and extend it to that because it's a unit project, not something that you do within weeks. Adhere to my academic dishonesty policy. Every action has a reaction, so be careful. Procedural skills mean that you know how to do the steps, but conceptual skills means applying the skill, how and why, answering those questions as you do the concept skills. Review grades on the weekly and discuss at the end of class. All right, so what I'm planning to do, just to get you acclimated into the new system of instruction, you're going to see symbols throughout the presentation. This symbol right here is me providing you instruction. This symbol right here is you doing the work independently. A few of you guys are still struggling with that. From the dome to the paper. That means from the brain, not Google, because I told you guys this semester it's all about the skill. All about the skill. There's no other way but skill. Okay, you see a teacher with a clipboard. As I told you guys before, I'm just taking notes, observing you. Of course, I'm not going to respond to you because I got to see what you guys are working with. I got to see the skill. All right? So when you see other people come in my classroom observing, not saying nothing to you, except for tell me what what you currently learning, that's what's going on. So I know that in the rotations, I've been training you to not ask me questions when I'm with other groups of students and only ask me at specific times. So this still somewhat applies to our new form of instruction. Group work. You always gonna have some time to do group work regardless. So after you do your independent work, after I have observed and took my notes, do your group work. Everybody got to play an equal part. There shouldn't be people doing the majority of the work. Because if I'm watching you and you sitting there not saying too much, grade is going to be an issue. All right. So after you had did the independent work and the group work, then that's for me to, go over wherever I need to go to. I will answer one or two questions and I'll move it along. Now, I am going to say this. I'm going to get through my lesson quick because I do want you to have a chance to work in groups and do all that stuff. I work with people who desperately need the help. And of course, after we get through with the lesson, you will have time to ask me questions, which you are still considered the participation grade. All right, so I want you to take a moment, pause this video, review this information, and answer the questions. I will not give you an answer because I want you to, get involved and see what can you do and just drop a comment in the comment area. So pause the video and see what you got. All right. By now you should have watched the video. You should have paused, then watched the video and answer those questions. If you have not done so, please do so. All right. So today we're talking about angles in a circle. I can't understand angles in the standard position. Here's the goal of today's lesson. I don't know if I said this, but if I did, this lesson is two parts. So, our vocabulary is standard position of an angle, initial side, coterminal angle, radian, radian measure, and unit circle. All right. The success criteria for this presentation is to apply previous knowledge such as coordinate plane. So you have to know that there's four quadrants in the coordinate plane, and when you make a full rotation, it's going to look like a circle, which gives you 360 degrees when you make that full complete one rotation. So, trig ratios, that's going to be done on day 2. Scan the walls for supplemental information. So if you forget the formula of a circle, all the information is on the wall. Just look for it. Use decimals well to simplify rational numbers. I know for sure many of us need that level of assistance of simplifying rational numbers, so use decimals well. Engage in mathematical discourse. No one should be silent. Everybody should be really seriously engaged into what's going on. Follow mathematical protocols. So I told you what to do and what not to do in the math class. All right. So now this is me teaching you. So here's the essential question of today. How can we study trigonometric ratios to angles greater than 90 degrees? Now, this is what we're focusing on. So this is the conceptual understanding. So this is the how and the why piece. How can you express an angle measures in the coordinate plane? Now, go back to the success criteria and use your knowledge of the coordinate plane. We discussed it already, so go back to the video when I discussed that success criteria part, and let's get back to it. The angle is in standard position. So we know how to draw angles. So usually they look something like this. Well, the vertex is at the origin. So that's our vertex right here. And the initial side is the angle that's in the positive x-axis. So that's right here. So that's the initial. And then the terminal side is the other ray. The other ray that forms the angle. Now, you guys know a thing or two about degrees, but I need to introduce something new to you, and we call this theta. So, an angle theta is measured counterclockwise from its initial side to its terminal side. So theta is more in terms of trying to figure out the particular angle. You don't know the degree. Well, the degree is the exact measurement. Theta is what you're trying to find, like when you're solving your equation trying to solve for x. And here we are. Now, these two words are going to be very, very important for us to know. All right, so now we're going to take our knowledge of the coordinate plane to answer this question. Again, we know that the coordinate plane has 4 quadrants, and when we make a complete rotation, and we rotate the quadrant plane around, it's going to make a circle, which we know that circle has 360 degrees. So now, with that being said, we are asked how can you express an angle measures in between the coordinate plane. So we know we got 4 quadrants, and we know that the complete rotation is 360. So when we divide 360 by the 4 quadrants, we know each quadrant is going to have by 90 degrees. So in quadrant 1, there exists a theta angle, which we don't know, that is between 0 degrees and 90 degrees. That's how you express angle measures in the coordinate plane. Again, theta, you don't know what the angle is. Degree is what the angle is. All right? In quadrant 2, we know we add another 90 to 90, we get 108 degrees. And we could say there's an angle theta that's between 90 and 180. Again, I'm simply just using my previous knowledge of a angle. Of the coordinate plane. All right. In quadrant 3, I know if I add another 90 to 180, I'm gonna get 270 degrees. I could say in quadrant 3, theta is between 180 and 270. And again, I'm doing this expression, the angle measure. Theta represents the unknown. I don't know what my angle is at the moment. And then in quadrant 4, I can say there is this a theta that's between 270 and 270 plus 90 gives me 360 in quadrant 4. All right, they tell us to sketch 210 degrees angle and a 315 degree angle on the coordinate grid. So they just telling us to sketch. So we already don't figure out using our previous knowledge. And y'all gotta forgive my drawing, but we know that we have 4 quadrants, and we know when they make a complete rotation, it's 360 degrees like a circle. Well, it makes a circle, and it has 360 degrees. And we know that in quadrant 1, you're gonna have between 0 and 90 degrees, or the maximum degrees in quadrant 1 is 90. We know in quadrant 2, the maximum degrees is 180 degrees, and we know in quadrant 3, the maximum degrees you can have in quadrant 3 is 270. Now, they told us that we have to sketch 210 and 315. Now, if you're someone who's like me, who's follow things literally, you know that 210, you know you're going to put 210 somewhere over here. You're going to draw it close to 180 because you know that 210 is closer to 180 than it is 270. And you're also going to look at 315 like, oh, 315 is between 270 and 360 degrees. And I'm going to draw it close to the middle because that's what it looks like. It's just right smack in the middle. Now, in your textbook, they tell you that since 210 is your terminal angle, or your terminal ray, as I would call it, you're going to go, you want to subtract 210 from 180, and that's going to give you 30. And then over here in your textbook, they're saying that the terminal side is of 210, of 315. 315, you want to subtract 360 minus 315, and they're going to give you 45 degrees. Now, this is not important to do, but these two numbers, 30, 45, are going to be very critical going what we're doing in this lesson. All right, so this is what your textbook have done. So, just like I told you, they realized the terminal side of 210 is 30, and they did it by subtracting 210 from 180, which gives you 30. And also, when it comes to 315, they realize that the terminal side is 315 is going to be, 315 is going to be 45 because you subtract 315 from 360, which which gets you your answer. Well, I mean to say 360 minus 315, which gives you 45 degrees. So that's what your textbook done. And again, those degrees are going to be important. All right, so let's get into some detail here. The conceptual understanding of this. How can you represent negative angles and angles with measures greater than 360? So the first one, that's what we do on a normal basis, dealing with what we're going to be dealing with. These two, you won't be seeing them too much. However, I do want you to understand that when you're trying to do with a positive angle greater than 360, so you add 120 to 360, that's going to be 480. So that's going to be right here because you went 360 plus 120. And that's where 480s come from, right there. Now, when you try to showcase a negative measure, it's going to go clockwise, not counter. Counter's positive. So we're going clockwise, like from here, you're going to go 120 minus 360. And that's going to give you that negative 240. Because when you're dealing with negative rotation, you have to have a negative answer. So make sure you guys pay attention to that and make sure there's no positive answers when you're doing negative angle measures. All right, and when it's positive, well, it's positive. But if it's positive greater than 360, it should be greater than 360. So just keep that in mind. But take note, since all these three angles we just talked about share the same terminal side, meaning that they're all right here, and all three, that is going to be called your coterminal angle. All right, get ready to try to do a problem of your own. Of course, do the try problems, do them by yourself. Use your notes, pause the video, see what you got. you should be back. You should be able to figure this out. So, positive, negative, and an angle greater than 360 for each angle. Now, I'm going to leave B for you to kind of wonder about, but we could do A. So, we know that the terminal segment, ray, forgive me, I'm tripping with my geometry vocabulary. Anyway, we know that this is 180 degrees, right? So we know that for it to be positive, it's 180 degrees because it's like it's in quadrant 2. The terminal side is, so that's 180. Now to make it negative, we're going to go 180 minus 360, and when you do that, that's just negative 180. Don't forget degrees, degrees, degrees. When it's positive greater than 360, so 360 plus 180, and when you add that, you should have your answer for that particular angle. All right? So that's all you have to do. Just like that. Right. So, of course, if you are in the classroom, I'm taking notes of your performance or what you did with people or what you did by yourself. I'm still going to be taking notes. You're working in groups. And, of course, I just reviewed the information. And, of course, that'll be your time to ask me questions. All right. So, how can you express angles in the coordinate plane using radian measure? So, angles may be measured in radians as well as degrees. In a circle, an angle that measures 1 radian has an arc equal to the radius. So that arc length is equals to its radius, but it's 1 radian. So the relationship between radian measure and arc length is going to be S equals theta times radius. So that's just giving you some knowledge, a little bit information. You don't need to do too much with that, just have it down pat. Alright, so now we're about to understand the radian measure on the unit circle. So now this is about to become procedural. Well, it's about to end conceptually, and we're about to get into the procedures of things. So, the circumference of a circle is 2 pi r, and we know r is the radius. Therefore, in radian measure, a full revolution around the circle is going to be 2 pi radius over over r equals 2 pi. So, hopefully, if I was tripping, that notation is called theta, the one I'm highlighting. So, a full revolution around a circle is theta equals 2 pi r divided by r equals 2 pi. We know that the r's cancel out. So a circle with a radius of 1 centered around the origin is the unit circle. And you can use the unit circle to determine the measure of an angle in radians. So I'm going to explain what they did in blue momentarily. Right now, let's just pay attention to the stuff in red. So again, we know that the 4 quadrants have a maximum of 90 in each. So you start quadrant 1 with 90, quadrant 2 180, 3 270, 4 360. So don't worry about all the ratings and stuff, because we're going to get into that soon. All right. Now, I know this is at the end of your textbook, but I want you to have an opportunity to see how this all work in terms of the unit circle. So when you try to deal with radians, you're going to go to 180. You're going to go pi divided by 180 times the degrees. So here's an example. So again, we know about degrees. We don't know anything about theta. I mean, radians. We know nothing about radians. So let's start with the degrees we know. So 90 degrees. So if I multiply this by pi over 180, now listen up. Let me get you guys together, because you guys going to have a tendency of doing this in decimals. You cannot multiply 90 times pi over 180. You cannot do that in decimals. It will not be allowed. Well, it would work, but it's going to throw your answer off. So in decimals, all you gotta do, instead of doing theta, go 90. I'm sorry, y'all. My color. 90 divided by 180. And when you divide that, that's going to be 1/2, which we know that's going to be pi over 2. That is how you convert. That's how you how you find the radians, by using your degrees and converting it. And the pi you're going to put at the end of your answer, as you saw. So 180 degrees, if I'm trying to find the radians of that, divide that by 180. And when I divide that by 180, that's just going to be 1. But don't forget, formula uses pi, so you can have just 1 pi or just pi by itself. Now 270 degrees, pi divided by 180. And again, do not put this in decimals like this. Get rid of the pi, and when you divide 270 into 180, you're going to get 3 over 2 and put the pi at the end. So I taught you how to convert into radians, degrees. Let me show you how to go from radians to degrees. Say that you had 30 degrees. I'm sorry, pi over 6. And I'm trying to figure out the degrees of the radians pi over 6. So, putting this in decimals, pi over 6, you're going to not put pi over 6. It's going to be 1/6 times 180 over 1. You can put that in, that's fine. When you do that, it's going to simplify to 180 over 6, which is going to give you 30 degrees. And that's how you do that. Just like that. So pause this video, take note of it, and then let's just move on. All right. So in example 2b, they just want us to sketch pi over 6, 2 pi over 3rd, 7 pi over 4. Now, instead of position. Now, Our you, convert each one of those into degrees. And that's how you're going to figure that answer out. All right. So again, we just did pi over 6. So 2, let's do the middle one. 2 pi over 3 times 180 over pi. Now, I'm pretty sure because you have the variable, so it's not of pi, it may or may not simplify in decimals. But if I were you, I would use my math skills and realize that the pi's cancel out. So pi is gone, so 180 times 2 is going to be 360 divided by 3. And when I divide that by 3, I know that's going to be 120 degrees. That's what you have to do. Simple, just like that. That's how you sketch. All right, get ready. Try to do this on your own. Sketch. Do the best you can. Now, you're going to have to not only apply this example that was taught to you, now you got to go back to other examples that was taught in this lesson. So pause the video, try it out. All right. Remember, I'm not going to, well, I won't do this for you, but I'm going to give you a hint for you. So when you do a negative 5 pi over 6, you know it's negative. So you know you're going to go clockwise. So you know you're going to go that way. So you got radians and you want to convert it to degrees. Remember, multiply everything by 180 over pi. You know your pi is going to cancel out. And just multiply and you should have your answer. And from there you should be able to know how to sketch. Again, you're using what was just discussed and you using stuff over from the beginning of the lesson. All right, so I monitored. You did your group work, and I just went over it. All right, you guys getting the hang of this. So now you're gonna do example 3 with me. So everybody come together. Let's do this together. I'm waiting for someone to call the answer out to me on this one. So convert it to degrees. Again, use your concept summary note. Convert it, you should have an answer. And when you did that, you realize that you got 225 degrees. Good job, y'all. Convert 75 degrees into radians, which if you could do one, you could do the other. You're going to divide 75 into 180. Now, oh, do not forget, in decimals, you can simplify. Make sure you hit the simplify button on decimals. All right, and that's the summary. Make sure you keep that in mind. All right, try this on your own. I'm not going to discuss it in this video. I want you to see what you can figure out. All right, that was the end of day 1. So this is day 2, but I'm not going to say anything here, so I'm going to end it right here. And whenever I get a chance, I'll post a video for day number 2.